Hello and welcome to Space Shark Teaches. I'm Sean from Space Shark Studios, and I'm here to teach you GDScript in Godot 3.1. Let's get started. Well, now that we have an animated platform, we want to make sure and hit up the most important thing to animate, which is our player. So we're actually going to be using a different method to animate the player sprite this time. So instead of an animated sprite, we are going to be using his regular sprite, but we're going to be using what's called a sprite sheet. So in the video description, you can grab this hero sheet, and we're going to be pulling this hero sheet in and using it. Like normal, when we pull it in, we have to go up to Import, Presets, 2D Pixel, and click Re-import. That just makes sure that things don't get all blurry and nasty looking. Once that's done, we can take this new hero sheet and drag it into the texture box. And now you can see what it actually looks like. It is 8 separate images. The 4 on the top are animation frames of the player going right, and on the bottom are 4 animation frames of the player going left. So we're going to be telling the sprite to use each one of these individually and updating which one it's on based on the scripts that we wrote. It won't work like this though, so we're going to have to go in to our inspector, down under Sprite, click on Animation, and we're going to be setting the number of vertical frames and horizontal frames. As you can see right now, there are 2 rows, which means that we need to set this to 2. There are 4 columns because there are 4 animation states in every direction. So H frames are 4. And now our player is back to how they're supposed to look. Frame uses this cutout that we just made to say which piece should we be drawing right now. And as you can see, it can only go between 0 and 7 because we have 8 different states. All right, so good. Our sprite is ready. So let's get into our script. We're going to be adding a new section down here for animations. We're going to start by having a variable called current frame that defaults to 0. We are going to export a variable called move right start frame. Now remember, that is the frame. If you reset these back, that is this frame. So the start frame, the first frame of the player moving to the right. Just like here, we're going to be using this one as the start frame. So this is 0, 1, 2, 3, 4, 5, 6, 7. So the move right start frame is 0, and the move left start frame is 4. And then finally, we want to say how many frames per animation happen. And that's going to be 4 as well, because we have 4 distinct frames that get played to make one animation cycle. So we can actually comment this and say the frame we are currently on, first frame of the right movement animation cycle, first frame of the left movement animation cycle. The number of frames in a full animation cycle. So you're going to be taking this current frame, so 0 through 3. We're going to be adding whatever this start frame is, so we know which of the one of these we're in. So if we say we're in, current frame is 2, so we're going to be in this column, and we'll know which one of these we're at by adding this to it. So if it's 2 plus 0, we get 2. If it's 2 plus 4, we get this one, we get 6. And the frames per animation make sure that we don't bleed into the next animation cycle beneath it. So now we're going to add a new function called animate. And I'm just going to put pass in here for now so it doesn't yell. We're going to add animate up in physics process underneath move. So the last thing the physics process does is it animates. So now let's go ahead and see what animation actually means. Well, we have the current frame, and we want the current frame to be the current frame plus 1. Except like we set up here, we only want it to be able to go up to 3. That way it's 0, 1, 2, 3, which is 4 frames. This means that it will forever go up, and that's a bad thing. So we are going to be putting that in parentheses and using a special operator called modulo. Now what modulo does is it gets the remainder of a division. So in this case, if A is 25 and B is 26, we say we want to divide 25 into 6 parts. Or basically, we want to take as many chunks of 6 out of 25 as possible, and then give me whatever you have left. So 25 modulo 6, using long division, you can see there are 4 batches of 6 in 25, and that leaves you with a remainder of 1. Over here, we can see if we have 13, and we want to get its modulus 4, then 4 goes into 13 3 times, which makes 12, leaving a remainder of 1. So in this case, we're never going to be going up above. You can basically think of it as we're going to be doing 0 modulo 4, which is 0, or 0, 1 modulo 4, which is 1, 2 modulo 4, which is 2, 3 modulo 4, which is 3, and then 4 modulo 4, which has a remainder of 0. And now we go back to the beginning here. So that makes it pretty easy to see how we can use this to make sure that we never go too many steps in the wrong direction. Because if we're going right and it goes around, or it loops around too many times, the animations will be looking left. And if we are moving left and our current frame goes too high, well, then we don't have any sprites for that. So I will just leave this here. So you can look at it if you use this code. But now we have the current frame. So what do we want to do? Well, we want to update this sprite, right? Because we have this frame. So how do we do that? Well, we can't just do that. That gets its name. We can't really drag anything in here and have it do anything for us. We actually have to use a new variable. And so we call onReady, which means that if you remember up here in this ready function, it's like calling it in here and setting it. It just means that this variable will only be instantiated and set when ready is called. So onReady var sprite, we want to get node, and this will list all the nodes available. Dot is the player, and if you see up over here, we have collision shape 2D, we have sprite, and we have camera 2D. So we're going to be using sprite, and now we have a reference to our sprite, and the sprite that is the child of the player. Awesome. So if we wanted to, we could just say now sprite.frame equals current frame. Let's see what happens. Well, we're animating now, and we're only animating to the right. But we show that we can animate. So let's go ahead and actually make this animation correct. So we'll hold on to that, and we'll say if, remember we have movement velocity, if the movement velocity in the x direction is greater than 0, we are moving to the right, which means we want our sprite frame to be our current frame plus our move right start frame. So remember, this means that if we are moving to the right, our speed in the x direction is positive. We want to set the sprite's current frame to our script's current frame plus the move right start frame. That's working. It's really easy to do the same thing in the other direction. Less than 0, and sprite frame equals current frame plus move left start frame. Save that. And now we are doing current frame, which is 0 through 3, plus 4, and now we're using the correct animations on both sides. Awesome, you are now animating. We can remove this, and that's it. That's all there is. We update the current frame's value, and then we say, here's the frame that we need to use to the sprite. In the next lesson, we are going to be smoothing all this out. The reason it's moving so fast, remember, is because physics process runs technically 60 times a second. That's a little bit too fast for our animations, so we will be putting code in to control that animation speed through a variable, just like we've done with move right start, left start, and frames per animation. So I'll see you then. Thank you for watching Space Shark Teaches. If you'd like to see more, please subscribe to the channel and remember to click the bell to always stay up to date. Please also join us on our Discord, linked in the comments, and check out our other videos if you ever want to see what else we've been up to. Thanks again for watching, and we can't wait to see what you make.